not a lot of it. So we're going to start 5.4 today, but we're not going to, tomorrow's a quiz day. So we won't pick back up on 5.4 again until Monday. Okay. All right, so let's go ahead and get started with graphing a logarithm. See if I can get my screen to work. Doesn't really want to. There we go. Sometimes I have to write on it. Okay. So first of all, a log is the opposite of an exponential. So in math, everything has an opposite. So the opposite of a square is a square root. The opposite of addition is subtraction. The opposite of multiplication is division. The inverse means opposite. So the inverse of an exponential is a logarithm. And we usually just say log. Instead of saying logarithm, we just abbreviate it LOG. Okay, because it's the inverse, everything about this graph is opposite what you will see in an exponential graph. So the first thing first, remember that for an exponential, which is what's on your quiz tomorrow, your domain is always all real numbers. Well, for a log, it's the range that doesn't change. This will never change. This is always going to be all real numbers. Instead of having a horizontal asymptote, we have the opposite. The opposite of a horizontal asymptote would be a vertical asymptote. Notice that these two are controlled by h. So your vertical asymptote will always be at x equals h. And your domain will be from h to infinity. Because there's a wall, the graph cannot extend all the way to the left and the right. It depends on where we draw our wall. That's going to determine where our domain begins. And also keep in mind that just like with an exponential, I am not using brackets. It will never be h, it just gets really close to h. So there are 3 tables that we're going to make. And as we progress through this, you may discover that you don't need to make all 3 tables. Maybe you just need to make 2. Okay? The first thing I'm going to do is create an exponential table using the base. And then I'm going to create the log by flipping the x and y column. And then my third step is to apply my transformations. Whenever you apply your transformations, it will always be x plus h and y times a plus k. So let's look at this equation. The a value is the number in front of log multiplied by log. H is inside of your parentheses, and you have to flip the sign, and k is in the back. All right, so we have 4 logs that we're going to graph today. So let's go ahead and do our first one. So this is just a basic log, okay? In this log, your a value is 1. The h value is inside of your parentheses. So there's invisible parentheses with a plus 0. Whenever you don't see parentheses, that just means h is 0. And k is also 0. Okay, so let's go ahead and create our table, our exponential table. What is the base of this log? What's the little bitty number next to log? 2. So let's make our exponential table. Y equals 2 to the power of x. We're not going to graph this table. We're just going to create our table. So if you need to quickly type in 2 to the negative 1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. Get your 5 y values. Okay, so 2 to the negative 1 is 0.5. Anything to the power of 0 is 1. 2 to the first is 2. 2 times 2 is 4. 2 times 2 times 2 is 8. All right, so now let's take this table and find the log base 2. So to find the log base 2 of x, because your calculator has a log key, but it's a log base 10 key. So you really can't use your calculator to figure out what is the log base 2 of a number. So that's why the easiest way to do it is to just flip your table. So what you're going to do is take your table. All of your y values are now your x values. So I'm going to take these 5 numbers and put them in my x column. Yep, this is always how you're going to do it. You're going to flip your table. And then your y values are your old x values. So all I did was take my points and reverse them. That is how you find the inverse. Now, before I graph it, I want to fill in my domain, range, and vertical asymptote. What did we say h was in this graph? 0. So my domain will be 0 to infinity. The range never changes. For a logarithm, it is all real numbers. It's the opposite of an exponential. Everything in this graph is opposite of an exponential. And we have a vertical asymptote at x equals 0 or x equals h. So I'm going to draw in, if you have a highlighter, feel free to draw in your vertical asymptote at x equals 0. And then you are only going to graph this table. This is all we're graphing. We're not graphing the first table. And if you feel like you can make your table without creating the first table, that's fine. So I'm only graphing the second table. It should look like a lowercase r. So I'm going to go ahead and graph that in. All right, so x point, okay, so 0.5, negative 1. You switch from highlighter, okay. Okay. And then 1, 0, 2, 1, 4 up 2, 8 up 3. So you're going to connect it, and it goes straight down, just like so. And that is your graph. That is what a log looks like. So we're going to do 3 more graphs, and then the next 3 will have some transformations. All right, so for our example 2, I'm going to go ahead and create my y equals 2 to the x table again, even though you should have it right above it. I'm going to recopy it. This time I'm going to have 3 tables. So that's my first table. That's just my exponential table. Now I'm going to create my log base 2. This is without transformations table. So now let's talk about AH and K. So now we have an A, H, and K value. So what's the number in front of the word log? When you don't see a number, that means that it is 1. I'm going to write it in though. So A is 1. H is always inside of the parentheses and opposite. So in this example, H would be 2, positive 2. And K would be positive 1. So let's draw in our vertical asymptote. Our vertical asymptote is at x equals h. And h is 2, so that would be x equals 2. Go ahead and pick up your highlighter, color pencil, draw in your vertical asymptote at x equals 2. Your domain is 2 to infinity. And your range is all real numbers. All right, so now we're ready to apply our transformations. So I haven't graphed anything yet. I didn't graph the first two tables. So now we're getting ready to graph. So I'm going to add the h to x, multiply y times a, and add k. So h is 2, so I want you to add 2. And then multiply your y values times a and add k. So you're multiplying by 1 and adding 1. And now that third table is the table that you will graph. I'm going to make that table in green. So go ahead, quickly figure out what these 5 numbers would be when you add 2. And then figure out these 5 numbers when you multiply by 1 and add 1.
When you're finding the domain, it's h to infinity?
Yes.
What if it's exponential? Or the range is h?
It's k to infinity. All right, so let's go ahead and when you get your new table, make sure, because I'm not using a calculator, so just want to make sure that those are the actual points you get. Notice that all of my x values, none of my x values are less than 2. So because your h value is 2, you should never get a number on this side that is, it shouldn't even equal 2. It should always be greater than 2. And that is what your graph should look like. So when you graph an exponential, usually we have 3 tables. The first one is our exponential table, which is optional. If you feel like you can skip that first table and just start at the second table, that is fine. And then we flip our exponential table to create our log table, and we apply our transformations to the log table. All right, any questions over example 2? Anybody need more time to copy down example 2? All right, let's go to example 3. What's the base? What's the little bitty number next to log? 3. So I'm going to make my exponential table for y equals 3 to the x. This time, I'm going to stop at 2, because if I do a 3 to the third is 27, and that's way too big. So I know I can't fit that. I know the highest I can fit on the grid that I have is 3 squared, because 3 squared is 9. So that's why I'm only stopping. I only have 4 numbers. So with your calculators, quickly figure out what 3 to the negative 1 is, 3 to the 0, 3 to the first, and 3 to the second. All right, and then the next table you're going to make is a log base 3 of x. That's without any transformations. So we start with y equals 3 to the power of x, and then we go y equals log base 3 of x. So to figure out this table, I'm flipping my x and y. So all of these numbers are now my y values. And then my first column is my x is my old y values. I'm still not graphing this because we have some transformations that we have to do. So A is 1. What would H be? Negative 4. And what is K? Negative 3. So let's draw in our vertical asymptote. So for this one, our vertical asymptote is at x equals h. H is negative 4. So go ahead, pick up your highlighters. Drawing your asymptote at x equals negative 4. And now let's apply our transformation. So to my x values, I am adding negative 4. And then to my y values, I am multiplying by 1 and subtracting 3. And of course, you really don't have to write multiply by 1 because if you multiply by 1, that doesn't change. But I'm just adding it so you always remember that you are multiplying by a. So go ahead and do that. Pick up your calculators and create your final table. And that final table is the one you will graph. Did I do that right? Negative 4 plus 0.3? No, it's negative 4 plus 0.3, not minus 0.3. So your range is negative 4 to infinity. So that means that you shouldn't have any points. If it was negative 4.3, That would be on the left side of the wall. We can't have any numbers on the any points on the left side of our wall. So your domain would be h to infinity. So what would that be? What would you write? -4 to infinity. And your range would be what? All real numbers. All right, I want you all to try to do example 4 by yourself. Take about 5 minutes. Create your 3 tables, and then we'll go through it together. Okay, so in this graph, or this function, A is 2. What is H? H is what? -3, and K would be -4. So we have a vertical asymptote at x equals -3. Your range is all real numbers, and your domain is -3 to infinity. I'm going to draw in my vertical wall, and then I'm going to add in my transformation. So I'm adding 3. And then for my y values, I'm multiplying by 2 and subtracting 4. Okay. So we're going to do our final table. So for my final table, I would have a -2.5, -2, -1, 1, and 5. And then I have 3 times 2 is 6. 6 minus 4 is 2. 2 times 2 is 4. 4 minus 4 is 0. 2 minus 4 is -2. 0 minus 4 is -4. And -2 minus 4 is -6. Again, this is what I am going to graph, only this. And when I graph it, I'm left with, so -2.5 go down to the 6. Then at -2, you go down 4. At -1, you go down 2. 1 is 0, and 5 up 2. Still only on the right side of that asymptote. And that would be your final graph. So this is 5.4. Remember, tomorrow's quiz is over 5.1 through 5.3. Everything is posted on Canvas. We're going to resume 5.4 on Monday.